Hello everyone. Let us now discuss the solutions to today's physics exam. Question 1. Free vibrations are the vibrations under the influence of a periodic force. This is not correct. Vibrations with larger amplitude, again, this is ambiguous. Vibrations when the frequency continuously decreases, this also is not correct. So the only correct option here is D, vibrations with a constant frequency and constant amplitude. So question 1, option D is the answer. Question 1, the second part, it says the diagram below shows 4 sound waves. Which sound has the highest pitch? Now we've got to select that diagram where the frequency is the highest. So if the frequency is highest, the pitch will also be the highest, and that will correspond to the second option. So question 2, the answer was B. Highest pitch, highest frequency, wave 2. Question 3, the graph plotted for potential difference against current for ohmic resistors is. Now we all know that if we have an example of an ohmic conductor, the graph of V versus I is a straight line that passes through the origin, and the correct option in this case is option C, a straight line passing through the origin. Next, a main switch in the main distribution board. This is not the switch for any appliance. It is for the main distribution board. And if you see the diagram, it is connected in both live as well as the neutral wire. So that is option C. So question 4, the answer is C. Okay. Question 5, a conductor AB is kept along the north-south direction of the earth above a magnetic needle as shown below. When the key K is closed, then we'll have to select one of the 4 options by first marking the direction of current. So current will leave the positive terminal of the cell and then it comes back via the negative terminal. And if you check the direction in which the current is flowing, it is from south to north. So I'll first write S, then N. Now the conductor is kept over the magnetic needle, and there is a rule which is called as snow rule, which says that if current flows from south to north, if the conductor is over the magnetic needle, then the magnetic needle points towards the west, and therefore it is option D, the needle will deflect towards west. Next, question 6. A coil wound around a piece of soft iron can become an electromagnet only when a current flows in the circuit. Only when the current will flow through the wire, then we can expect the coil to start behaving like an electromagnet. This is basically Hans Oester's experiment, an extension of his experiment. Okay, question 7. If water absorbs 4000 joules of heat to increase the temperature of 1 kg through 1 degree Celsius, then the specific heat capacity. So here heat is given, mass is given, change in temperature is given, and we've got to find the specific heat capacity by using the formula Q is equal to mc delta T. On substituting the value of heat as 4000, mass as 1, C is to be found, and delta T is the change in temperature, which is also through 1 degree Celsius. That means delta T is equal to 1. We get the value of C as 4000 joules per kilogram per degree Celsius. But if you read the options are in terms of joules per gram per degree Celsius. So we can convert joules per kg per degree Celsius into joules per gram per degree Celsius by dividing this with 1000. So when 4000 is divided by 1000, we get 4, and therefore the answer for this is 4 joules per gram per degree Celsius. Next question. Water is used in car radiators because its specific heat capacity is high and it can cool the engine without any substantial increase in its own temperature. So this actually comes from the high specific heat capacity of water, which is 4200 joules per kg per Kelvin. Therefore, for question 8, the answer is D. The heaviest nuclear radiation is alpha. Alpha radiation, it has a mass which is equal to 4 times AMU. 1 AMU is 1.67 into 10 raised to minus 27 kg. And if you compare this with beta, beta is almost 7,200 times lighter than alpha. And when it comes to gamma, gamma is massless. So its mass, in fact, cannot be compared with alpha or beta at all. So alpha is the heaviest. So that is option B. Next, to study the age of excavated material of archaeological significance, we study the rate of decay of an isotope of carbon. It is C14. Therefore, for question 10, it is option C. Okay, so now let us go to section B. Question 2, the diagram below shows a magnetic compass kept closer to a coil AB wound around a hollow cylindrical cardboard. Let's read the first question. After studying the circuit and the magnetic compass carefully, state whether the switch S1 is open or closed. It is closed. How did you arrive at the conclusion? Before reading the answer, I'll explain it to you. If this circuit were to be open, there would be no current flowing in it. If there is no current flowing in it, there'll be no magnetic field produced. In that case, the compass needle will point towards the north pole of the Earth's magnetic field. But as you can see here, the compass needle is not pointing towards north. It is pointing elsewhere, which means there is some other stray magnetic field. And that is because of this electromagnet, which means there is current flowing in this, which basically means that the switch S1 is closed. Now, while writing the answer, you had to just say compass needle not pointing towards north. Or you can also say compass needle not pointing in the expected direction. Or if you want to elaborate on this, you could have also said compass needle points in the direction of the resultant magnetic field, which is towards the south, which means that there are two fields present. What is the purpose of placing the compass needle in the above step? The only reason why we use a compass needle is to detect the presence of an external magnetic field due to the electromagnet. So by using the compass needle, we were able to judge whether the switch S1 is open or closed. So imagine a situation where the compass needle would not be there. In that case, by simply looking at the diagram, we will be in no position to judge whether there is some current flowing in the circuit or not. So basically, the functionality of the magnetic compass is only to detect the presence, and not only detect, but also show the direction of the magnetic field that is due to the electromagnet. Okay, question 2, the second part. Give an important reason for copper to be used as a material for a calorimeter. Out of the 3 reasons that are there in the textbook, only any one reason is required here. Either you could have written that it is a very good conductor of heat, that means it has high thermal conductivity, or you could have said that its specific heat capacity is low, or you could also have said that copper can be beaten into thin sheets and this causes the heat capacity of copper to drop. So any one of these 3 reasons. Next, calculate the thermal capacity of 40 grams of water whose specific heat capacity is given. Now thermal capacity is represented by the symbol C dash. It is equal to the product of mass and specific heat capacity, all values to be substituted in the corresponding units. Now mass is given in grams, so I'll substitute that as 40. Specific heat capacity has been given as 4200. We cannot take that because that is in joules per kg per degree Celsius. We had to take 4.2, and on multiplying this, we would get 168 joules per degree Celsius as an answer. That is the value of heat capacity of water. Question 2, the third part. There's a circuit given where there are 3 resistors. 2 of them are in parallel, 12 and 8, and their effective is in series with 2. We have been given the current that flows through the 12 ohm resistor, and let us see what is to be found. The first thing to be found is the external resistance of the circuit. That is easy to find. We had to first find the equivalent of 12 and 8 by using the formula 12 into 8 divided by 12 plus 8. So this is 4, 3 times, 4, 5 times, 24 by 5, which is 4.8 ohms. That is the effective of these two. Now 4.8 and 2 ohms are in series, and therefore we'll add them directly, and the answer will be 6.8 ohms. 6.8 ohms is the external resistance of this circuit. Okay, now to find the second current I2, we will have to use Ohm's law. We will first determine what is the voltage across these 2 terminals of the 12 ohm resistor. We know the value of current, which is 0.4. The resistance is 12. We can make use of the formula V is equal to I into R. So I is 0.4, R is 12, 0.4 into 12 is 4.8 volts. That is the voltage or the potential difference across the 12 ohm resistor. Now 12 and 8 are in parallel. Therefore, the voltage across 8 ohm will also be 4.8. So I'll make use of the same formula V is equal to I into R. This time I is I2 and R is 8, and I2 will be 4.8 divided by 8, and the answer is 0.6 amperes. So current I2 is 0.6 amperes. Finally, we had to find the total current I. So current I enters this combination. It gets divided at node A into two branches. The branch above carries 0.4. The branch below is carrying 0.6. Therefore, I, the main current, is actually equal to the addition of the two secondary currents. So it is 0.6 plus 0.4, and that is equal to 1 ampere. Okay. Question 3, the first part. Three wires with proper color coding are connected to the three terminals of a 3-pin socket. Match the color of the wire with the proper terminals. Now, before we go to the terminals, let us see the colors and write down what wire each color represents. Brown is for life, green is for earth, and light blue is for neutral. Now, earth is this pin, or rather this socket hole at the top, that is A. So green is basically matched to A. C is the terminal on the right, and that is always for live. And this leaves us with B, the terminal on the left, and that is matched with light blue for neutral. Question 3, the second part. Why does it become colder after a hailstorm than during or before the hailstorm? So after the hailstorm, the hailstones, which are basically ice crystals, they absorb heat from the surrounding so that the ice crystals melt. Now we all know that ice has a very high latent heat of fusion, and that had to be mentioned here, which is 336 joules per gram. That means for every gram of ice that melts, that absorbs heat from the surrounding, 336 joules of energy is lost from the surroundings. And this basically contributes towards cooling the surrounding. So you had to write here, ice has a high latent heat of fusion, 336 joules per gram. For every 1 gram of ice at 0 degrees Celsius, 336 joules of energy are absorbed from the surrounding for it to melt. And because of this, it becomes very cold after the hailstorm. Lastly, question 3, part 2, subpart B. If two bodies have the same specific heat capacities, then they will always absorb the same amount of heat if their temperature increases by the same amount. State whether the above statement is true or false. The statement is false. It is false because this happens only under certain conditions. And one condition is, two bodies having the same specific heat capacity, they will absorb the same amount of heat if their temperature increases by the same amount and if they have the same mass. So mass is the condition. Only when the mass is same, then this statement is right. Otherwise, we cannot accept this as a general statement. So you had to just write false here. Okay, so the next question is question 3. The third part, it's a question based on calorimetry, where principle of mixtures is used. There is a metal piece of mass 420 grams that is at 80 degrees Celsius. It is dropped in 80 grams of water present at 20 degrees Celsius in a calorimeter of mass 84. If the final temperature of the mixture is 30, then calculate the specific heat capacity of the metal piece. Now, before we solve this question, we should know that the metal piece being at 80 degrees Celsius is the hot body, and the calorimeter along with the 80 grams of water that is present in it, they become the cold bodies. So let's substitute heat lost. So we'll have the hot body here. So only one term because there is only one hot body, the metal piece. Its mass is 420 grams. Its specific heat capacity is to be found. So I'll call that as X. Its difference of temperature, it is initially at 80 and finally at 30. So difference of temperature is of 50 is equal to, now let's take the second term for water. So its mass is 80 grams that is given in the question. Specific heat capacity is 4.2, and this is initially at 20 and later on the final temperature becomes 30. So difference of temperature is of 10. Then the last term, M3, C3 and delta T3, that is for the copper calorimeter. Its mass is given as 84 grams. Its specific heat capacity is given as 200 joules per kg per degree Celsius. So we divide this by 1000 and this becomes 0.2. 0.2 multiplied by delta T3 Again, copper calorimeter is assumed as the same temperature of water initially, that is 20. Its final temperature is 30. Therefore, the difference of temperature will be of 10. On multiplying the first term, 80 into 4.2 into 10, we get 3360. And the second term, 84 into 0.2 into 10, we get 168. Addition of these two terms is 3528. And the left hand side is 420 into 50, that's 21,000 into x. And when you solve this for x, it is 3528 divided by 21,000, which is 0.168, but that is in joules per gram per degree Celsius. But while presenting the answer, it should always be in the SI unit, and therefore it is 168 joules per kg per degree Celsius, or better if you write 168 joules per kg per Kelvin. So that is the answer. Okay, question 4, the first part. Rohit played a flute and Anita playing a piano emit sounds of the same pitch, that means the same frequency, and the same loudness, which means amplitude is also same. Name one characteristic that is different for waves from the two different instruments, that is quality or timbre. Because pitch is same, loudness is also same, so that we are only left with quality that helps us in differentiating between the two sounds. If now the loudness of the sound from the flute becomes 4 times than that of the sound from the piano, that means loudness of the flute is 4 times the loudness of the piano. Write the values of the ratio amplitude of the flute to amplitude of the piano. So loudness of the flute is 4 times the loudness of the piano. This is given in the second part, but we know that loudness is proportional to amplitude square. So if you take the ratio of loudness, that will be equal to the square of the ratio of the amplitudes. Now ratio of loudness is 4:1 for the flute and the piano. Therefore ratio of their amplitude squared will also be 4:1. And now when you take the square root, the ratio will be 2:1. So the ratio for amplitude of the flute to amplitude of the piano is 2:1. Define pitch of a sound. Pitch is the subjective nature of frequency that helps in distinguishing between two sounds that have the same loudness and the same quality. Question 4, the second part, A. Name two factors on which the force experienced by a conductor carrying a current placed in a magnetic field depends. The first factor is the current flowing through the conductor, and the second factor is the strength of the magnetic field. There is one more factor, which is the length of the conductor present in the magnetic field. So any one of these three, in fact, any two of these three had to be written. I would go with current and magnetic field. And how do these factors affect the force? They affect the force directly. Question 4, the second part, question B. With the help of which rule you can determine the direction of force acting on a current carrying conductor? This is Fleming's left hand rule. Question 4, the third part. After emission of a nuclear radiation, the atomic number of the daughter nucleus increases by 1. Identify the nuclear radiation. It is beta radiation or beta emission. Write a nuclear reaction indicating the nuclear change mentioned in B. So here you can give the example of C14 getting converted to nitrogen and releasing a beta particle. Mass number, it remains same. Atomic number, it increases by 1. What is the special name given to the parent and the daughter nucleus when this radiation is emitted? So there is no change in the mass number, even though atomic number has increased. Such special elements are called as isobars because their mass number is unchanged. Question 5, the first part. An appliance is rated 440 watt, 220 volts. Maximum current that it can draw, we can use the formula P is equal to V into I. So I is equal to P by V, which is equal to 440 divided by 220, and this is equal to 2 amperes. So maximum current that this appliance can tolerate is 2 amperes. Then to find the resistance, we can use either V is equal to I into R, or P is equal to V square by R. I'll go with V is equal to I into R. So R, the resistance will be V divided by I V is 220, I is 2, and this is 110 ohms. So resistance is 110 ohms. Question 5th, the second part. The diagram below shows a vibrating tuning fork E mounted on a sound box X. When the vibrating tuning forks A, B, C, and D are placed on the sound box Y one by one, it is observed that a louder sound is produced when the tuning fork B is placed on Y. What is the frequency of tuning fork E? Now, louder sound is being produced. That means there is resonance, which happens when the two frequencies match. So frequency of fork B is 320 Hertz. That will match with the frequency of tuning fork E, and therefore the answer is 320 Hertz. Only for writing this, you will get full marks. Then why does B produces a louder sound? You can say it is because of resonance, the phenomenon of resonance. You can also add since the frequency of B matches with the natural frequency of E. Question 5th, the third part. From the graph of heating curve given below, state the melting and boiling point. So melting point is this first horizontal section of this graph. It corresponds to the temperature for this horizontal section, that is 40 degrees Celsius. And the boiling point will be for the second horizontal section, that is 160. So 40 and 160. 40 is for melting point, 160 is for the boiling point. Complete and rewrite the following nuclear reaction. Now it's a reaction that shows an alpha decay. So we are expecting the mass number to reduce by 4. So from 235, it will become 231. So mass number for thorium is 231. Now atomic number of thorium is 92. So earlier it must have been 2 more, and therefore it is 92 there. So uranium 235, 92, thorium 231 and 90. That is how we fill the two blanks. Question 6th, the first part. Study the figure and answer the following. What type of vibration does the above figure represent? So it is representing damped vibrations. That is because the amplitude is steadily decreasing, damped vibrations. Then state one reason for which the amplitude of the vibration decreases with time. It is due to the presence of a damping force, an external damping force, which causes a loss in energy. And this basically causes the amplitude to reduce over time. There's no need to mention that it's the force of friction, because there are many examples of damping force. One of them is force of friction, but it's better to say the presence of an external damping force which is causing the energy loss. That is the reason for which the amplitude decreases with time. An example of natural vibrations, you can say a tuning fork or an oscillating pendulum, but in vacuum. The word in vacuum is very important. Next, the second main question, a certain beam of particles, a certain beam of alpha particles, beta particles and gamma radiations travel through a region of electric field produced between two oppositely charged parallel plates. Which of the above three has the maximum speed? It is gamma. Which one deviates the most from its original path? This is beta. Which one does not deviate at all when passing through a region of electric or magnetic field? That is again gamma. Okay, the last question. If a wire of resistance 2 ohms is stretched to thrice its original length, calculate the new resistance of the wire. Now here we had to use the formula R1 upon R2 is equal to rho 1 upon rho 2 into L1 by L2 into A2 by A1. Now it's a wire which is stretched. So its new length L2 is 3 times its original length. So L1 upon L2 will be 1:3. Increase in length will be complemented by a reduction in area. So A1 upon A2 will be 3:1, reciprocal of L1 upon L2, which means A2 upon A1 will be 1:3. So let's substitute these values. R1 upon R2, R1 is the original resistance, which is 2. R2 is the new resistance that is to be found. It's the same wire, so rho 1 and rho 2 will get cancelled. L1 upon L2, the ratio is given as 1:3, and A2 upon A1, the ratio was found to be 1:3. 3 into 3 is 9. 9 goes there. Therefore, the new resistance of the wire is 18 ohms. What happens to the specific resistance of the wire? It remains unchanged. So with that, we end the solutions. Thank you.